Welcome back. This is a video for Econ 100B, Intermediate Micro. Today we're going to look at the participation activity for monopolies. Remember, monopolies are a deviation, sort of the other extreme of competitive markets. And this participation activity looks at a lot of the things we've dealt with in this chapter, calculating marginal revenue, determining the profit maximizing price and quantity for a monopolist, calculating the deadweight loss or the loss to society, the welfare cost of a monopoly, and then what governments can do in some cases to create monopolies. And that's a big part of what we talked about. So we'll try to hit a lot of the big ideas in this chapter, in this assignment. So let's get started. The first thing we have is we are given a inverse production function, or an inverse demand function rather, and we want to use that inverse demand function, cost function, to determine what the marginal cost, average cost, and marginal revenue curve all are for this company. And so what I'll do is we'll calculate the curves, talk about that, and then we'll go ahead in the next step and graph it. So the first thing you want to notice is, let's get these curves up here. We have an inverse demand function of P equals 90 minus 2Q. And so if we want to generate the marginal revenue curve, we remember that the formula for marginal revenue is that marginal revenue is equal to P plus change in P over change in Q times Q. We can insert this equation in for P. We can insert this in for the slope of the demand curve, the effect a change in price has on quantity demanded. And so we get a marginal revenue curve that is equal to 90 minus 2Q plus negative 2 times Q, which will simplify down to marginal revenue equals 90 minus 4Q. And that makes sense. That's what we expect. We expect the slope of the marginal revenue curve to be twice as steep as the slope of the demand curve. So I'm going to go ahead and erase this and hold on to these, hold on to all of these equations up here on the side, because we'll use them when we do our graphic. So we've got inverse demand is P equals 90 minus 2Q. Marginal revenue equals 90 minus 4Q. And then the next thing we have is the cost function. And this is not something we've learned in class, but I'm going to show you how to find the marginal cost function too. So we're given the cost function, which is that cost as a function of the quantity is equal to Q squared. So we want to use that to find marginal cost and average cost. Oops. So marginal cost is given in the problem, but real quick, I just want to show you finding marginal cost is basically just taking the derivative of this equation with respect to Q. So the derivative of cost with respect to Q. And what we do with that is we just take the exponent and reduce it by 1 and bring it down in front. So we bring this exponent down in front too. We keep Q. We keep any component that has a Q. Anything that doesn't have a Q falls away. So if this had been, plus 100, that would have fallen away. And then we reduce the exponent by 1, so it's down to 1. So we just are left with 2Q. Hopefully that's a little bit helpful. If it's not, don't worry about it, but it's a really easy way to generate that marginal cost curve, and it is given in the problem. So now we have marginal cost is equal to 2Q, and then average cost is going to be Q squared divided by Q, because average cost at any level is going to be cost divided by Q. So that gives us an average cost function that's just Q. Okay? So far, so good, right? Pretty straightforward. So we've used the cost function to find average cost, and we calculated the marginal revenue curve. And now what we want to do is determine the profit maximizing quantity and the price that a monopolist will choose. So if we want to find the profit maximizing quantity, we need to set marginal revenue equal to marginal cost. And so we have marginal revenue is 90 minus 4Q. Marginal cost is 2Q. So I'm going to say it's going to be 90 equals, add 4Q to both sides, 6Q. So that's 90 divided by 6. Q equals 15. So our monopolist is going to produce a quantity of, there we go. Our monopolist is going to produce a quantity of, I'm going to call it QM actually. There we go. QM is 15. And then to find the price that the monopolist would charge at that quantity, we just insert it into that inverse demand function up there at the top. So we've got price equals 90 minus 2 times 15, which is 90 minus 2 times 15 is 30. So the price is going to be $60. Cool. So the price the monopolist charges is going to be $60. So now we've gotten pretty far, right? Now we've got all of the elements we need to graph this curve. And again, I don't think that this should be too stressful graphing these. You want to try and hit all the high points and do the best you can. And sometimes it should tend to work out pretty well. So let's go ahead and graph these in our market. So we want to start with the inverse demand curve. To find the places where the inverse demand curve, which is linear, hits the price axis and the quantity axis, we set price equal to 0, which gives us 90 minus 2Q. 2Q equals 90. Q equals 45. So at a price of 0, the quantity demanded is going to be 45. And then if we set Q equal to 0, then we get P equals 90 minus 2 times 0. P equals 90, right? So let's do 10, 20, 30, 40, 50, 60, 70, 80. A little bit higher. 90. Okay, and then across the quantity, we want to go all the way out to 45. So let's say 10, 20, 30, 40, 50, 60. And that should give us our demand curve. So that's our demand curve, which is a function of price. And then we want to draw in our marginal revenue curve. Our marginal revenue curve is going to have the same point up here of 90, the same sort of origin point at the price level, but it's going to have half the slope, and it's going to cross here at half the point that the demand curve would. So if the demand curve crosses at 45, the marginal revenue curve is going to cross at 22.5. So we'll just sort of do that like there. And you can calculate that the same way, right? We can go ahead and say, okay, take marginal revenue and set Q equal to 0. You're going to get price, marginal revenue is equal to 90. If we set marginal revenue equal to 0, we're going to get 4Q equals 90, which is Q divided by 4 equals 22.5. So far, so good? This shouldn't be too hard, right? This is pretty straightforward. This is maybe easier than some of the stuff we've done so far. Now we want to put in marginal cost and average cost. So our marginal cost curve is going to be 2Q. So for every value of Q, we're going to have the marginal cost be twice that. So it's going to be basically a steep slope, right? So I'll go ahead and graph that. And the thing I want to know is I want to find, well, I've already found the point at which marginal revenue is equal to marginal cost. That is at a quantity of 15. Oh, yeah. That's a little bit wobbly. Let's put it all the way over there. It's a little bit uneven. Let's see. There we go. That'll do it. So at a quantity of 15, we've got the price is going to be $60 and the marginal revenue of 90 minus 4 times 15 is going to give us our point at which it crosses the marginal revenue curve, which is 15 times 4, 60, 30. Yeah, that doesn't quite cross right. I didn't do my marginal revenue curve great. Must have the scales off a little bit here. There we go. So that's going to be the quantity at which our monopolist produces and the price they charge right there, which tells me that my marginal cost curve is going to go through that point also. And I can find my marginal cost curve with that point, and I can set Q equal to 0 or marginal cost equal to 0. If I set marginal cost equal to 0, it's going to give me 2Q. Divide. Oh, it's not going to work. Let's do it this way. Let's set marginal cost equal to 2 times Q. If Q is 0, marginal cost is equal to 0. So it's going to be from the origin to here. And then we can find, just draw this out. Okay. That's our marginal cost curve right there. Okay. So now we've got our marginal cost curve drawn in. We also want to draw our average cost curve. I'm going to grab one more color because you can't have too many colors. And our average cost curve is basically just going to be a ray out of the origin, because average cost is equal to quantity means it's going to be 10 to 10, 20 to 20, 30 to 30, and so on. So that's our average cost curve. Cool? So far, so good. What we'll want to do is, now we've got our demand curve, our marginal revenue curve, marginal revenue curve, average cost curve, marginal cost curve, and our equilibrium price and quantity for our monopolist. And so the next thing we want to do is talk about the welfare loss associated with our monopolist. And to do that, we have to determine the competitive price and quantity for the market. So that means we got to find where a perfectly competitive market would be if this were a perfectly competitive market, which means we don't want marginal cost equal to marginal revenue, because in perfect competition, marginal cost would actually be set equal to the demand curve. And that's the trick, because marginal cost hits demand, that's the point at which a perfectly competitive firm would be, right? Their marginal revenue would be equal to that demand price. So that's that competitive price. So if we set marginal cost equal to our inverse demand function, that's going to give us 2Q equal to 90 minus 2Q. I'm going to add 2Q to both sides and get 4Q equals 90, which means that Q is going to be equal to 90 divided by 4, which is again 22.5. And the price at that point is going to be P equals 90 minus 2 times 22.5, which gives us a price of 45. 22.5 times 2 is 45, so price equals 45. So that's going to mean this point right here, right? That would be the competitive quantity and competitive price. Does that make sense? Now we can talk about the welfare cost, right? And this is the part we did talk about in class. Y'all said you were comfortable with it, so it shouldn't be challenging, but you want to look at the consumer surplus associated with the market without a monopoly. So if we had that perfect competition outcome, what would the consumer surplus be? What would the producer surplus be? What would total welfare be? And then all I'm asking you to do is calculate the dead weight loss associated with a monopoly. So remember that dead weight loss is going to be the difference between, sorry for my chair, this perfect competition equilibrium and this monopolist equilibrium. Oops. That pen is not fine enough. There we go. Here's the super fine black pen. It's lost forever. So it's going to be, the dead weight loss is going to be this triangle here. So we can just calculate the area of the triangle for the dead weight loss, which has a base of 30 and a height of 30, right? 45 minus 15. So 1/2 of 30 times 30 is 900 divided by 2, or 450. What are the welfare costs associated with the monopoly? Well, we see consumer surplus fall. It would have been, without the monopoly, we would have seen consumer surplus be this area of this large triangle here. Let's try and make that not so bright. But consumer surplus shrinks up to this smaller triangle. Producer surplus increases from being this equal sized triangle here to this much larger trapezoid, because now they're charging a higher price and a lower quantity, so they're generating a lot more revenue. And then the dead weight loss to society is that $45. We can also calculate the profits associated with this monopoly. And so that would be looking at the price and the average cost at the given monopolist quantity. So profits are going to be equal to revenue minus cost, or we can just calculate it as the price minus average cost times quantity, which is going to be 60 minus average cost at a quantity of 15 is 15 times a quantity of 15. So, 60 minus 15 gives us 45 times 15 gives us profit of $675. The last thing I want you to think about for this problem is how the government might try to solve this monopoly problem. So one thing they can do is, if it's a natural monopoly, they can try to regulate it. They can impose a price ceiling. If they imposed a price ceiling, that would look like this. They would say, okay, the price is set at the competitive price. Rather than $60, the price is going to be set at $45. And so we see the demand curve change to this level. And we see the marginal revenue curve would now look like this. And so that's one way that the market would change if it was regulated. So that's basically it. That's a lot of what we covered in this chapter. Hopefully that gives you a sense of everything we've talked about and what's going on in monopolies. And you're ready to move on next week to monopolistic competition and oligopoly. Let me know what questions you have. Hopefully this participation activity is a good practice for you. And I'll see you next time. Thanks so much.